Did you know the moon is getting smaller? Or that Earth once had 2 moons? Or that there are actual moonquakes happening right now? We're about to blow your mind 20 of the most insane, unbelievable facts about our planet and its closest neighbor. Some of these sound completely made up, but I promise you they are absolutely true. We're going to count them down from 20 to the number 1 most shocking fact that will completely change how you see the sky. This is going to be an absolutely wild ride, so get ready. This is a quick 10-minute countdown for YouTube. Stick around for the surprise fact at number 1. It's a game changer. I'm Sherry. If you're as obsessed with space as I am, you're in the right place. We're diving deep into the weirdest and most wonderful secrets of our cosmic home. Before we start this crazy countdown, if you love space facts, smash that like button and subscribe right now. It literally takes 1 second and it helps a ton. All right, the clock is ticking. Countdown starts now. Kicking off our countdown at number 20 is something that affects every single one of us every day, and we don't even realize it. The moon is basically Earth's cosmic bodyguard, keeping our climate from going completely haywire. Without the moon, Earth's axial tilt, the angle our planet leans on its axis, would wobble like crazy. I'm talking massive, chaotic swings over thousands of years. This isn't just a small change. We're talking about a wobble so extreme that the North Pole could end up pointing directly at the sun. Imagine a world where your home city experiences months of total darkness, followed by months of scorching, unending daylight. That's the kind of chaos we'd be dealing with. The moon's gravitational pull acts like a giant stabilizer, holding Earth's tilt steady at around 23.5 degrees. This stability is the reason we have predictable seasons and a relatively stable climate, which was absolutely crucial for the evolution of complex life. Without our lunar companion, life on Earth might not exist as we know it. So next time you look up at the moon, remember it's not just a pretty light in the sky. It's the silent guardian that prevents our planet from tumbling chaotically through space. It sounds like science fiction, but it's true. The moon's gravity is causing Earth's rotation to slow down. This process is called tidal friction. As the moon orbits Earth, its gravity pulls on our oceans, creating the tides. This massive movement of water creates friction against the seafloor, acting like a brake on our planet's spin. It's a tiny effect, but over millions of years, it adds up. How much is it slowing us down? Right now, it's lengthening our day by about 1.8 milliseconds every single century. I know, that doesn't sound like a lot. You won't notice it in your lifetime. But go back 620 million years, and the Earth day was only 21.9 hours long. Dinosaurs experienced shorter days than we do. This gradual slowing means that in the distant future, our days will be even longer. We might have to add a leap second to our clocks every few years just to keep them in sync with Earth's slowing rotation. So, the moon gives us stable seasons, but it also takes something in return: our time. This cosmic tug-of-war has been happening for billions of years. The energy that Earth loses from its spin is transferred to the moon, which actually pushes it into a higher orbit. But we'll get to that later in the countdown. It's an incredible exchange of energy between 2 celestial bodies, happening silently above our heads every single day. You might think the moon is just a big, dry rock, but for fact number 18, we're revealing a secret it's been hiding for billions of years. There's water on the moon. And I'm not just talking about the ice at the poles. Scientists were shocked when they analyzed tiny volcanic glass beads brought back by Apollo astronauts. Microscope close-ups of the beads show tiny structures. These little beads, no bigger than a grain of sand, were formed during explosive volcanic eruptions on the ancient moon. During those eruptions, water was spewed out with the magma. As the magma cooled rapidly into glass, it trapped some water molecules inside. The beads preserved those molecules for billions of years. Tiny time capsules. This was a massive discovery. For decades, we thought the moon was completely bone dry. Finding water inside the beads proved the moon's interior wasn't as arid as we thought. This water was likely part of the original material that formed the moon. the discovery changed how we see the moon's formation and history. It means building blocks of life, like water, might be more common in our solar system. It also has huge implications for future human exploration. If we can extract this water from lunar soil and glass, it could be used for drinking water, creating breathable air, making rocket fuel. The moon could become a literal gas station on the way to Mars. At number 17, we're looking at a fact that made our planet the blue, living world it is today. For the first half of Earth's history, our atmosphere was completely toxic to us. There was almost no oxygen. You would have suffocated in seconds. So what changed? A massive planet-altering event called the Great Oxygenation Event. Around 2.4 billion years ago, tiny microorganisms called cyanobacteria evolved a revolutionary new trick: photosynthesis. They started using sunlight to make food, and as a waste product, they pumped out tons and tons of oxygen. At first, this oxygen was absorbed by rocks and minerals on the surface, literally causing the planet to rust on a global scale. But eventually, these sinks filled up, and the oxygen started flooding the atmosphere. This was a catastrophe for most life on Earth at the time, which had evolved in an oxygen-free environment. For them, oxygen was a deadly poison, leading to one of the biggest mass extinctions in history. But this event paved the way for new, more complex life forms, like us, that could use oxygen to generate energy much more efficiently. It didn't just happen once either. There was a second major oxygenation event, hundreds of millions of years later, that raised oxygen levels even closer to what we have today. This shows how life itself can fundamentally transform an entire planet. We're literally breathing the byproduct of ancient bacteria. Without this dramatic and violent change in our atmosphere, fact number 16, Earth and the Moon trade rocks. This next fact sounds like a comic book. Earth and the Moon have been exchanging rocks for billions of years. It's called meteorite exchange. When a massive asteroid or comet slams into a planet, the impact can blast chunks from the surface, sending them into space fast enough to escape gravity. Those ejected rocks drift through the solar system as meteorites. Over millions of years, some get captured by another body's gravity and crash onto its surface. Scientists are almost certain rocks from Earth have landed on the Moon. One rock from Apollo 14 might be the first Earth meteorite found off-world. It contains minerals and chemistry that match Earth rocks better than lunar ones, like finding a piece of your house in your neighbor's yard, on a cosmic scale. There could be ancient Earth rocks, billions of years old, on the Moon, perfectly preserved in the vacuum of space. We also have lunar meteorites here on Earth. Over 300 have been found. They were blasted off the Moon by impacts and made the 239,000-mile journey to our planet. This rock trade means the Moon could be a museum of early Earth history. Earth is geologically active, plate tectonics, erosion. The Moon is a dead world that preserves geological artifacts, potentially holding clues about the origin of life. When you think of a giant volcano, you probably picture Mauna Loa in Hawaii, Mount Fuji in Japan. But the single largest volcano on Earth is completely hidden from view. It's called Tamu Massif, located about 1,000 miles east of Japan, deep beneath the Pacific Ocean. It covers about 120,000 square miles. That's roughly the size of New Mexico, or the British Isles. For a long time, scientists thought it was a complex of many volcanoes. Then seismic studies showed it's one single, gigantic shield volcano, formed about 145 million years ago by a massive outpouring of lava. Its peak sits more than 6,500 feet below the ocean's surface. You could sail right over it without knowing. What makes it special isn't height, but its incredible breadth and low, gentle slopes. It's a completely different class of volcano. While Olympus Mons on Mars is taller, Tamu Massif is a strong contender for largest by area in the solar system. Discovering this monster shows how much of our planet is still a mystery. The deep ocean holds secrets as alien and awe-inspiring as other planets. There are giants hiding in the abyss. Coming in at number 13 is a chemical mystery, When we compare rocks from Earth and the Moon, we find something very strange. Lunar rocks are severely depleted in what are called volatile elements. These are elements and compounds like water, sodium, potassium, zinc that have low boiling points. On Earth, these elements are relatively common, but on the Moon, they're mysteriously missing. It's a huge clue about how the Moon was born. The leading theory, which we'll get to later, involves a colossal impact. The extreme heat generated by this event, we're talking thousands of degrees, would have been hot enough to vaporize these volatile elements. They would have literally boiled away into space before the material that formed the Moon could clump together and cool down. Only the elements with very high boiling points, the refractory elements, were left behind to form the bulk of the Moon. This chemical signature is one of the strongest pieces of evidence supporting the giant impact hypothesis. It's like baking a cake at way too high a temperature. All the water evaporates, and you're left with a dry, crumbly mess. The Moon is essentially the dry cake of the Earth-Moon system. This depletion of volatiles tells a dramatic story of a fiery, violent birth that forever shaped the Moon's composition. For fact number 12, we're tackling a common misconception. You've probably heard that the Moon is tidally locked, meaning it always shows the same face to Earth. And that's mostly true, but it's not the whole story. Thanks to a cool phenomenon called libration, the Moon actually wobbles in its orbit. That wobble lets us see a little bit more of its surface over time. So instead of just 50%, we get to peak at around 59%. There are a few types of libration. The main one is due to the Moon's elliptical, or oval-shaped orbit. The Moon spins at a constant speed, but moves faster when it's closer and slower when it's farther away, letting us peak around the edges. There's also a daily libration caused by Earth's rotation. Viewing angle shifts between rise and set give another tiny peak around the limb. Have you ever looked at a crescent moon and noticed the faint outline of the rest of the lunar disk? It's not your eyes playing tricks on you. That ghostly glow is called Earthshine. It's literally sunlight. It has bounced off the Earth. It then traveled to the Moon to illuminate its dark side. You're seeing the Moon lit by our planet. Imagine an astronaut standing on the Moon. When we see a crescent, they'd see a nearly full Earth. Our planet is covered in bright clouds and reflective oceans. Earth is much larger and more reflective than the Moon. A full Earth in the lunar sky is over 50 times brighter than our full Moon. That brightness can cast a soft, gentle light across the lunar landscape, making the dark parts visible to us on Earth. Leonardo da Vinci figured this out over 500 years ago. He realized Earth reflects sunlight like the Moon. So that faint glow is a cosmic reflection. Sunlight traveled 93 million miles to Earth, reflected to the Moon, then 239,000 miles back to your eyes. It's an amazing three-way light show. We're at the halfway point with fact number 10, and it's a tale of two moons. Fact number 9 is a geological shocker that happens right here on Earth. Our planet's magnetic field, the invisible shield that protects us from harmful solar radiation, is not stable. It has flipped upside down hundreds of times. This is called a geomagnetic reversal. The magnetic North Pole would wander to the south, the magnetic south to the north. Your compass would point the other way. Reversals happen at irregular intervals, tens of thousands to millions of years apart. The last full reversal was about 780,000 years ago. The process isn't instantaneous. It can take several thousand years. The field weakens and becomes multipolar, with multiple norths and souths. Swirling liquid iron drives it. A weaker field could affect satellites and power grids. Our planet is dynamic to its core. The side of the Moon that faces us, the near side, looks completely different from the side that faces away, the far side. The near side is covered in large, dark, smooth plains called maria, or seas. These are ancient lava flows that filled in giant impact basins. But when we first saw the far side in 1959, we were stunned. It was completely different. The far side is almost entirely covered in craters, rugged and mountainous, with very few maria. Its crust is also significantly thicker, up to 30 miles thicker in some places. Scientists think Earth's radiant heat kept the near side more molten longer, leaving a thinner crust that let magma flood impacts, while the far side cooled thicker and just kept craters. The Earth itself sculpted the two faces of the moon. You've heard of earthquakes, but get ready for fact number 8. The moon has moonquakes, seismometers left on the lunar surface by the Apollo astronauts, detected thousands over the years. Unlike earthquakes from tectonic plates, moonquakes are different. Deep quakes from tidal forces, rare, powerful shallow quakes, meteorite impact quakes, and thermal quakes at sunrise. Some moonquakes can last for over an hour, enough to violently shake a future lunar habitat. The moon still groans and shifts under Earth's pull, and these quakes let us probe its interior. Holding strong at number 7, Earth is constantly losing its atmosphere to the cold vacuum of space. The process is called atmospheric escape. It's like our planet has a very, very slow leak. Don't worry, it's tiny. We're losing about 90 tons per day, minuscule compared to the whole atmosphere, plenty to last billions of years. Lightweight hydrogen and helium in the exosphere get heated by the sun and reach escape velocity, boiling off the top. The solar wind can also strip particles, especially near the poles where our magnetic field funnels them. For Earth, it's trivial. For Mars, it was devastating without a strong magnetic field. Our field helps keep our air and habitability intact. At the lunar poles, there are craters that are permanently in shadow. Their floors haven't seen direct sunlight in over 1 billion years. With the sun always low, rims cast permanent shadows. Some of the coldest places in the solar system, colder than Pluto. And what do you find in these ultra-cold, dark places? Water ice. Lots of it. Over eons, icy impactors delivered water. In sunlight, it vaporizes, but in permanent shadow, it freezes and accumulates. NASA's LRO and LCROSS confirmed significant ice deposits mixed into the soil. This may be the single most important discovery for human exploration, an in situ resource. Ice can be melted for drinking water, split into hydrogen and oxygen for air, and, most importantly, turned into rocket propellant. The moon could be a refueling station to Mars and beyond, letting us live off the land. These dark, icy craters could be the key to humanity's future in space. We're in the top 5. At number 5 is a bizarre motion our planet is doing right now that you can't feel. It's called the Chandler wobble, a tiny, irregular wobble in Earth's axis of rotation. Imagine a spinning top starting to wobble. Earth is doing that, on a planetary scale. The exact position of the poles wanders in a circular or spiral path, by about 30 feet at extremes. The wobble's period is about 433 days, one spiral per cycle. Discovered in 1891 by Seth Carlo Chandler, it puzzled scientists for decades. We now think it comes from changing ocean floor and atmospheric pressures, an imperfect wobble that changes size and shape. It reflects constant mass redistribution in oceans and atmosphere, showing Earth is a flexible, dynamic system in motion. Brace yourself for number 4. This is the incredible, violent story of how the moon was created. We are in the top 3, and fact number 3 takes us to the very center of our planet. The leading scientific theory is called the giant impact hypothesis. About 4.5 billion years ago, a Mars-sized protoplanet named Theia approached Earth. Theia slammed into the early Earth in a cataclysmic, planet-shattering collision, not a glancing blow. The impact obliterated Theia and blasted huge chunks of Earth's mantle into orbit, forming a superheated debris ring. Over hundreds to thousands of years, gravity clumped molten blobs that merged and coalesced into the moon. This single theory explains why lunar rocks resemble Earth's mantle, why the moon lacks a large iron core, why it's volatile depleted, and the system's unique orbital traits. Our moon isn't a captured asteroid. It is bone of our bone, rock of our rock, born from the most violent event in Earth's history. Earth's inner core, a solid ball of iron and nickel about the size of the moon, is rotating slightly faster than the rest of the planet. This phenomenon is called superrotation. The core spins independently inside the liquid outer core and laps the surface by about 1 degree every single year, like a spinning top inside a spinning globe. We can't drill to the core. Scientists use seismic waves from earthquakes and decades of timing data to detect the rotation difference. Swirling liquid iron that generates our magnetic field drags the core, and slippage lets it spin faster. It reveals a layered world with a heart that beats to its own slightly faster rhythm. This is it, the runner-up. Fact number 2 is both amazing and a little bit sad. The moon is slowly drifting away from the Earth, about 3.8 centimeters, roughly 1.5 inches per year, about as fast as fingernails grow. Billions of years ago, it was 10-20 times closer, looming huge in the sky and driving colossal tides hundreds of feet high. It's the other side of tidal friction. Earth spins down as the moon spirals out, conserving angular momentum. In the very distant future, Earth and moon may become tidally locked, a slow, inevitable breakup on a cosmic timescale. Right now, at this very moment, Earth might have more than one moon. I'm not talking about a big one like our moon, but tiny mini-moons. These are small asteroids, just a few feet across, that get temporarily captured by Earth's gravity. They orbit for a few months or even a few years before they are eventually flung back out into space or burn up in our atmosphere. This isn't just a theory. In 2006, we found 2006 RH-120, a car-sized object for about a year. In 2020, CD3, our mini-moon, for about 3 years. Simulations suggest that at any given time there's likely at least one 1-meter object orbiting Earth. They're so small and faint that they're incredibly difficult to detect. We don't just have one large permanent satellite. We have a constantly changing family of tiny temporary companions. We are constantly capturing and releasing these little space rocks. Our gravity is more dynamic than we thought. So the next time you look up, remember, besides our big, beautiful moon, there's probably a tiny secret moon up there too, a silent, temporary visitor. And that's a wrap. From Earth's super-rotating core to our secret second moons, our planet and its companion are so much weirder and more wonderful than we could ever imagine. We saw how the moon literally saves our climate, how it was born from a planetary collision, and how it's slowly drifting away from us. These aren't just trivia questions. These are the fundamental stories that made life possible. So, now I have to ask you, which fact surprised you most? Let me know in the comments below. If you had your mind blown today, smash subscribe and turn on notifications. Thank you so much for watching, and I'll see you in the next one.